Now we are going to discuss about balancing chemical equations. So according to the law of conservation of mass, before reaction and after reaction, the mass of the elements must be same, equal to the mass of the reactants is equal to the mass of the products. So that is law of conservation of energy. That's why here we need to follow that for balancing chemical reactions. And coming to the law of conservation of equal proportions, we know that the elements ratio before the reaction and after the reaction must be same. That means the ratio of elements, the ratio of atoms to corresponding elements must be same before and after chemical reaction. So that's why a chemical reaction in which the number of atoms of different elements on the reactant side are same as those as on product side is called as balanced reaction. A chemical reaction in which number of atoms of different elements before reaction and after reaction must be same. That type of reaction is called balanced reaction. So here we need to satisfy law of conservation of mass and law of conservation of equal proportions. So that we should follow here and we should satisfy those two laws. Then we will get the balanced chemical reaction. So the laws based on the Antony, Lavoisier Antony proposed those two laws we have studied in 9th class. So from the two laws here we are balancing the chemical equations. So first in that equation involves number of formula units we need to consider first. That means one formula unit is equals to the 1 unit, whether that is an atom, ion or a molecule also. So for example here NaCl we are taking Na plus ion and Cl minus ions we need to consider for one formula unit of NaCl. Here Na plus ion and Cl minus ion, like that. While coming to the another example, one formula unit of magnesium bromide. So is Mg plus 2 ions and 2 Br minus ions. 2 Br minus ions and 1 Mg plus 2 ion. One formula unit of MgBr is Mg plus 2 ion and 2 Br minus ions. Total 3 ions commonly called as MgBr here. One formula unit commonly we are calling that one. And one formula unit of water is H2O molecule that we know. And coming to the systematic method to balance the chemical equations, here we have 4 steps. In the first step, first we need to write, children, unbalanced equation or skeleton equation we should write with correct chemical formula of substance. For example, hydrogen reacts with water or else calcium oxide reacts with water. So first understand the correct chemical formula. That's why I have explained before yesterday 2 classes I have explained about that chemical formulas. So for that first you should write correct chemical formula for the substances. So that equation is skeleton equation. With the help of correct chemical formula for the given equation, given reaction, we can write. So that one is skeleton equation. So that may or may not be balanced. In the next step, we should compare the reactant side atoms and the product side atoms, LHS side and RHS side. Compare the number of atoms, how many number of atoms of hydrogen are there, how many number of oxygen are there in the left side, in the right side to the arrow mark. Like that we should compare and just add the coefficient. Don't compare with ratios, just coefficient you should. Ratios must not be. Just compare the coefficients and add the coefficient for balancing purpose. So after few steps we'll get equal ratios. So coming to the step 3. In the step 3 we should make sure that the coefficients are smallest whole numbers. So for that purpose we need to take the least possible factor. So till the no common factor we should divide it. with a suitable number to that coefficients. So then we will get the smallest possible whole numbers as coefficients. I think you got idea. So we will take another example like that, then we will get the idea. So after completion of step 2, we will get balanced equation only. But we should make the coefficients the smallest whole numbers. So for that we should divide with a suitable number, least suitable factor. So then if there is no common factor, we can leave like that. There is no need to divide the equation. In the step 4, verify the equation is balanced or not. So for this we can take the example like this. We can LHS side and RHS side, both sides we can write the all atoms like this. So then how many numbers of atoms left side and how many number of atoms right side, the ratio should be same. Then finally we can conclude that the equation is balanced. So like that here we got information, and we have discussed with common example H2O. Here I am taking skeleton equation of hydrogen reacts with oxygen will get water molecule. So that's why I wrote skeleton equation. In the second step I am comparing. So here two oxygen atoms, two oxygen atoms, but here only one oxygen atom. That's why I am adding that coefficient here. So then what happened? We got here 4 H2 and 2 O. So then we need to add here 2 H2 plus O2 gives rise to 2 H2O will get. So finally we got a balanced. So that's why we'll get here 2 H2 plus O2 gives rise to 2 H2O. So then finally we got a balanced equation here. So for that purpose 2H2 means 4H. Here also we have 4H, O2, 2O, 2O's. So we can also compare like this, LHS side and RHS side. Finally I am in the fourth step. There is no need to take any common simple number. No common number here. So no common factor for all the numbers. So no need to take any division process here. No need to take any common factor. And coming to the LHS side, here we have H and O atoms, H and oxygen atoms. And coming to the H, here we have 4. Here also 4 we have. O, here 2 we have, and here also 2 we have. So balanced, same ratios. So that's why this equation is finally balanced chemical reaction. So like that the water molecule will be we'll get from the hydrogen and oxygen. Then finally we got here a balanced chemical equation. So this is the way to balance chemical equation with 4 steps. This is the systematic method with 4 steps. So in this way only we will balance the equation. Then children will see combustion of propane. So prop, meth, eth, prop. Propane formula is CH3, CH2, CH3. So this I will explain you in the 12th lesson. Carbon and its compounds. So in that I will explain those names and all. So now you will take like that propane. So propane formula is C3H8. Like this we can write as compound of carbon. Then we will see after classes, after words those. And coming to the combustion of propane, here we are taking. Actually propane is a colorless, odorless gas, children, and often used as a heating of cooking fuel also. The propane we are using in our daily life as cooking fuel. And chemical equation we need to write for combustion reaction of propane. That means here propane and oxygen will react and the products will be carbon dioxide and water. So for this we need to write a skeleton equation first as first step. We need to write a skeleton equation. Write down a skeleton equation for propane plus oxygen reacts with each other, then we'll get carbon dioxide and water as output. So I am writing that from the given information about that reaction. Correct chemical formula I am writing. So propane plus oxygen will gives carbon dioxide and water. So for that I am writing just skeleton equation. Then in the next step, step 2, here we need to find out the coefficients to balance the equation. Just compare the coefficients parts. Compare the coefficients. Individually compare, not entire ratio. We need to take entire ratio. After completion of these balancing with coefficients, then we will get the ratios balancing. Balanced ratios we will get after completion of these coefficients balance. So then here carbon 3. Here we have only one carbon. So for that purpose, so in the next step, I am taking like here propane reacts with oxygen will give carbon dioxide and water. Here we are just comparing the coefficients, not entire ratios, individual coefficients. Here C3 we have, here CO2 we have. So 3 carbons. So for that purpose I am adding 3 here to balance that coefficient. We are adding that coefficient here 3. Don't take ratios, just coefficient. You have right to take coefficients, then the ratios will be balanced. You should not add any ratios here. Ratios means this number of atoms, you should not add this. So with the help of coefficients only we can have rights to balance that equation. We should not have right to add that ratios. So we should write only, we should balance only those. Here I am adding 3CO2, 3 coefficient I am adding here for balancing. 3 ratio of carbons I am adding here product side. To balance with reactant side I am adding 3CO2, 3 I am adding as coefficient. And coming to the next step, then afterwards here carbon balanced 3 3. And coming to the hydrogen, here height we have, here 2 we have. So for that purpose we need to multiply with 4. So 4 2 is 8 we will get. So C3 H8 propane plus oxygen gives rise to 3CO2 plus 4H2O. So then 8 hydrogen atoms balanced. And coming to the next, carbon balanced, hydrogen balanced. And coming to the oxygen, here only 2 ratio. Here we have 4. So for that purpose, so 4, and here also we have children, 3 2s are 6 and 4, 6 plus 4, total 10 oxygen atoms we have. So for that purpose here O2 only we have 2. So we need to take, we can take here 5, then 5 to the 10. Here I am adding 5 as coefficient. So C3 H8 plus 5O2 gives rise to 3CO2 we will get, then 4H2O. So this is the, I think, all balanced according to us. And there are, in the third step we need to compare and we need to identify or find any lowest common factor for all these coefficients. Just check. There is no common factor for all these coefficients because we need to make these coefficients as lowest whole numbers, but there is no possibility for that common factors. So leave like that step 3. And coming to the step 4, verify both sides. LHS side and RHS side we have carbon, hydrogen and oxygen. Carbon, hydrogen and oxygen. LHS side we have 3 carbons, 8 hydrogens, 5 oxygens. And RHS side also we have 3 carbons, 3 2s are 6 and 4. 6 plus 4, 10 we have. Here oxygens 5 to the 10 nana. Don't get confused. Here hydrogens 4 to the 8 we have. So balanced. So finally we got a balanced chemical equation. So this is our balanced chemical equation of propane combustion. This is balanced reaction for propane combustion. Here propane in the presence of oxygen we are burning. Then we will get carbon dioxide and water as output. So this is the balanced chemical equation for propane combustion. And coming to the another example from the textbook. So this you can understand, children. With the help of these 4 steps only we can balance that chemical equation, and with the help of a table also directly we can balance. So with these 3 steps we can balance, and with the help of this table from starting onwards also we can balance the equation. First skeleton equation, ferric oxide reacts with aluminium will get ferric will gives output as aluminium oxide iron. So here we got a skeleton equation from the given information. Then step 2, just compare the coefficients both side. Don't think about ratios. You have rights to add only coefficients. So likewise here we have Fe2, here we have Fe. So here I am adding 2 Fe. Then in the next step, ferric, so iron balanced. Then coming to the oxygen atoms, here 3 we have, here also 3 we have, no need to bother about that. Coming to the aluminium, here 1 we have, here 2 we have. So I am adding coefficient to the reactant side aluminium. For that I am adding 2 Al. So we will get equation like this, and there are I think all balanced aluminium, oxygen and ferrous iron. So no need to worry about that. In the step 3, no common factors for the coefficients all. So leave like that step 3. And coming to the step 4, just verify all the LHS side and RHS side. Ferric iron 2 and oxygen 3 aluminium 2 balanced. So we'll get balanced equation finally. So this is the information about balancing chemical equations, children. Then coming to the balance the following chemical equations, we have in the questions we have balanced chemical equations. So for that I have explained this. So in the further class we will discuss those. So and you can also understand with this explanation easy balancing of chemical equations. No need to worry, follow those 4 steps and use this type of table also. We can get idea and we can easily understand with the help of comparison like this from starting onwards. So here I am explaining like that, children. For this NaOH and H2SO4 skeleton reaction, I am taking first step from this only. I am taking like this LHS and RHS. Here we have sodium NaO and hydrogen we have SO4 ions we have. So and coming to the RHS side, sodium, oxygen, hydrogen and SO4. Just take first step 1 sodium, and coming to the oxygen, here we have only 1 year sulfate. This one I am taking as a single formula unit. Don't take this one as oxygen separately and sulfur separately. Here I am taking this one as single formula unit, SO4. So here O1 number of atoms and H1. And coming to H, here 1 and here 2, total 3 we have, children, 3 hydrogen atoms. Coming to the sulfate, here only sulfate ion 1 we have. Here coming to the right hand side 2 sodium and 1 oxygen and 2 hydrogens, sulfate 1. So here sulfate balanced only, no need to worry about that. And coming to the hydrogens, here 3 we have, here 2 we have. So for balancing this oxygen, no need to worry for that oxygen. And coming to the sodium, here we have 1 and here we have 2. So for that purpose I am taking here rather than 1, I am adding here 2 as coefficient in the step 2. So like this is the step 2 explanation, children. Just understand carefully. Here I am taking 2. So then sodium balanced. And coming to the, if we take 2 to the LHS side, the changes will come. Here also we will get 2. So here also we will get 3. Here we have already 2, we are taking 2 plus 2, 4 we will get. So like that, here changes will come. Due to this change we will get all changes. And coming to the SO4, there is no change. So for this, coming to the next step, we are going to take balance for all. Oxygen also we have changed, hydrogen changed. So in the next step I am adding 2 to the hydrogen, because here we have 2 hydrogen atoms and here we have 4 hydrogen atoms. Just I am multiplying here with 2 like this, 2 into 2. So here we can get 2 into 2, 4 I am changing. So 2 into 2, 4 we will get, means oxygen will also change here as 2, because I am taking coefficient 2 here. So for that we got here 2. So then oxygen balanced, hydrogen balanced, sodium balanced, all balanced. So finally we got a balanced chemical equation, 2NaOH plus H2SO4 gives Na2SO4 plus 2H2O. Like that we will get a balanced equation. Like this also we can understand step 2. For step 2, here I have taken like this. So I think you got clear information from these children. Thank you for nice class. We will see further tomorrow.